Hey everyone, it's Ali again, and today we are going to be talking about ionic bonding. Now, in the last video, we learned that atoms will bond to achieve stability. In chemistry, stability means having a full outer shell of electrons. So if an atom doesn't have a full outer shell of electrons, it is going to be unstable, and if it is unstable, it is therefore going to be reactive. So firstly, let us look at a representation of a metal atom and a non-metal atom. If we look at a metal atom, it has less than 4 electrons on its outer shell, and as a result, if it wants to achieve a full outer shell, the easiest thing for it to do is to lose those remaining electrons on that outer shell, lose that outer shell, and then it's left with an outer ring of 8 electrons, so a full shell is happy, is stable. For the non-metal, it makes a lot more sense for it to just gain however many more electrons to achieve that full outer 8. Okay, so what's important to note is that atoms have equal numbers of protons and equal numbers of electrons. So if you're going to go and remove an electron from one of these atoms, then that's going to produce an imbalance in the charges. So if we look at the metal representation, as we said, metals tend to lose their electrons, and what that's going to result in is more protons than electrons, and as a result, that particle now becomes charged and positively charged, whereas a non-metal will go and it will just gain more electrons, and as a result, there are now more electrons than there are protons, and as a result, the non-metal atom becomes negatively charged because there's more electrons. So metal atoms will lose their electrons, leaving them positively charged, whereas non-metal atoms will gain electrons, leaving them negatively charged. Now, the process of adding or removing an electron and becoming a charged particle is called ionization. An atom has no charge, whereas an ion is a charged particle. Okay. So once we form the metal ion and the non-metal ion, they become strongly attracted to the opposing charge of the other ion. And this forms a large repeating lattice pattern of positive, negative, positive, negative, positive, and negative ions. Ionic compounds tend to have high melting points and high boiling points, as it's the strong ionic bonds that need to be broken up in order to break up the lattice. So many ionic lattices tend to be soluble in water. This is because the water molecules are able to separate the ions and as a result lead to the dissolving of that substance. So ions can conduct electricity, but only when they're molten, as that's the only time when the ions are not tightly attracted and bound to one another and they're free to move. And remember, electricity is just the flow of charged particles. An ion is a charged particle, and as a result, if you can produce a flow of ions, then you can produce electricity. So yeah, ions are able to conduct electricity, but only in their molten state, because that's when the ions are free to move. Okay guys, I hope that's been informative, and I hope that's helped you understand a little bit more about ionic bonding. If you want a bit more information, you can check out our Instagram, where we actually have crisp infographics that help you understand the concept as well. Maybe if you're on the go and you just want to brush your knowledge, check out the Instagram. I'll leave a link down below. Thank you very much. Cheers, guys.